So we need to solve this system of equations. Now, some students look at these two and they're like, well, there's not really a definitive x equals or y equals. There is, it's right here. It's just written in a different format probably than what you'd expect. So if you would prefer to see it like this, then do it, all right? Because it means exactly the same thing. 2x equals y is the same thing as y equals 2x. And then even if you were like, you know what, I don't even want to look at that garbage, then don't. You can cover it up and, well, you still have the same equation. It's just written in a different way. But that's up to you. I'm going to keep both just so we know where it came from. But now that we have that, we're going to use substitution to solve this. And you could use graphing. It didn't say which method you have to use, nor would I really require any specific method. But substitution is going to be nice because I have a y equals, in this case, 2x. So I'm going to take that 2x, and then over here in the other equation, which is x plus y equals 15, well, we now know that the y value can be replaced with 2x instead. So I'm going to take the y, and I'm going to make it 2x. So what we talked about last time would have been that. At this point, in this equation, it used to have x and y variables, but now it has only one variable, which will help us to solve for the ordered pair, which is the actual solution to our system. Remember, you got an x and y value. So once we get those two, once we get the one x value, then we can solve for the corresponding y value. Now in there, I would show this as 1x, so that when I combine the two, how many x's is this? Well, 1 plus 2 x's would be 3 x's, and then this would equal 15. So we've just combined like terms to make the equation smaller. There was no need for distribution. And I can finish solving this equation by making the coefficient a 1. So I'd have 1x equals, how do we make that 3x a 1x? Simply take the 3 and divide it by itself. Now that is a principle of equality, so if you do it to one side, you'll need to make sure to do it to the other side as well. So 3 divided by 3 is 1, that was planned. 15 divided by 3 though, that was the unknown part, it's 5. So that right there, this part right here is telling us that x is 5 in this system of equations. So for my ordered pair, I have x is 5. A common mistake is for students to stop right here and say, well, look at all the work I did, and it's, it's pretty, you use some colors there. But it is not complete. You need a y value to complete the problem. Now, it doesn't matter which of the two equations you use to solve for the y, either one should work. So last time we talked about checking these things. I'm going to use the first equation though, just because it sets up very nice. Y equals 2x. Well, right now we're pretty sure the x is 5, so I'm going to take this x and replace it with 5. So the x, we're going to change it into a number that we're pretty sure it is, 5. And when I solve this, it should give me a y value. 2 times 5 is 10. Now that's y equals 10, so that means our y value in the ordered pair should be 10. Okay, but the last thing I would need to do here, just to make sure that I've done it correct, is to check. Now we don't have to check that first equation because 2 times 5 is 10. This one checks off. We've done it. If you replace the x with 5 and the y with 10, you do get a true statement out of this first equation. But it's the second equation that we have not checked. The second equation, x plus y equals 15. Well, we pretty sure we have x and y values here. So I'm going to take the x, and right now, pretty sure it's 5, so I'm replacing it with 5. And the y value, right now we're pretty sure that's 10. That's what we solved for. So I put in 10, and then I'm just going to check this for truthfulness. So there's my question mark over the equal sign. I don't know if that's equal. But 5 plus 10 is 15, and yeah, that actually does equal 15. That right there is a true statement, and since it is true, now I know I have found the solution. Two objectives for today. I can solve a system of equations with substitution. Same objective as last time, but today I'm going to throw in some word problems. We'll take a look. So take a minute, copy those down, then we'll get started. This is a slide we've already seen from last time. We need to remember that in some cases we may need to manipulate an equation for x or y. So like the bell word, one of the equations was already in a y equals format, or something like equals y. But we don't care if it's y equals or x equals. Either one of these will do, and once we see something like it, then we know that we can use substitution, because we'll have two equations. If we have x equals, we can replace x in the other equation with whatever this garbage is over here. Okay? Same with y. So if y equals some garbage, and we have another equation with a y there, just replace that y with this garbage from the other y. Okay? Because the y's are always going to be the same, or they should be the same for both equations in the system. So it doesn't matter which y you use or which x you use. You kind of get to choose as long as you have something to work with. So if it's necessary, you may need to actually manipulate some of these until you get y equals or x equals. And by manipulate, I'm talking about principles of equality, where you make zeros and ones. Kind of like you would with solving an equation, but this isn't going to be like a regular value or the x either. Okay? Now, once you get that, then you can determine what one of the variables equals the expression. So that we're looking at one of these. Okay, once you've manipulated it here, which sometimes we get to skip this first step, then we just see, well, y equals something and then x equals something, right? Then we take that, and then we know we're going to replace that into the other equation. So that's what we do for step 3. You take whichever one of these values you have and replace it into the other equation. Okay, now what that does, just like we saw on the bell work, it gives us an equation with only one variable, which once we solve it, then in our ordered pair, which is the actual solution to the equation, you'll have either an x or a y value. Okay, so you'll have at least one of those two values. Then you can go back to the original, one of the two original equations, and replace the value that you found, the number that you found. You can replace those x's or y's with the value you have, and then solve for the remaining unknown, which could be either one of these. And then the last thing we do, just like we saw on the bell work, is to check the other equation that we didn't use to find the second value. All right? So just kind of review, the reason why this is an ordered pair right here is because on a graph, which we had 2 lessons about, what you end up with is a line here and maybe a line over here, something like this. The solution is the ordered pair where the 2 lines connect. And that solution, that intersection between the 2 lines, is it's a location on the graph. But in addition to that, this ordered pair here is the only ordered pair that would make, because these 2 lines, they come from an equation. This ordered pair, since it's on the red line, it would make this equation true. But since it's on the purple line, it would make that equation true as well, which is why we check for truthfulness at the end. So to go back and just think about this just a little bit, if I had a point right here, this blue point, okay, this blue point is on only the red line right there, not the purple one. So if you were to check, you would find that the red one would be true, but the purple one would be false. I'm talking about the equations that made these. Because it's only on the red line. And then in a worst case scenario, sometimes we get a point over here maybe. In this case, this one is not on the red or the purple line. It's false for both. Okay, but we need it to be true for both of them. It needs to be true, like this green one, for the red and also the purple. Let's say you go through the checking process, number 6 here, and you're like, you know what? I found one of them was false. Then you're in this kind of situation with this blue point here on the red line. And if that happens, you got to go back and find out where you made a mistake. Usually it's just some kind of small mistake. Maybe you wrote down the number wrong, right? Instead of 15, you wrote down 16. Maybe instead of writing a negative, you wrote it down as a positive, something like that. And I'm saying you, but I'm really talking about me because those are common mistakes that I made. So I'll be using substitution. This one's pretty clear. We get to skip step 1 because there's no need to manipulate this first equation. It's already showing us as y equals some stuff. Now, I don't really care what the stuff is. It's negative 6x plus 8. I just don't care about it because it's showing me y equals. This tells me that I know I can substitute this stuff right here, as this y over here. Now, keep in mind, if this was like x equals, and maybe this was a y, then you'd be replacing the x. But for this particular problem, it's y equals. So here's what I'm going to do. I'm going to take that garbage right there, the negative 6x plus 8. That is y. That is what y is. And it should be y for both equations, which means that I can take the y in the other equation here, and I can replace that y with the garbage that the other y is, and that is negative 6x plus 8. Okay, so I replaced, mathematically, they would say substitute. Doesn't matter. Replace, substitute, it's the same thing. And now we have the rest of this equation. So now I've got 7x plus 2 times this purple parentheses, and then this would equal negative 14. Now, in case you were wondering, I do need this set of parentheses here, especially because it's 2 times all of the y. It's not just 2 times the negative 6x, we have to multiply by the 8. That is what we call distribution, which we've talked about before, we've seen extensively, and that is what I'm going to do next. So hopefully we remember that distribution is multiplication. So I'm expecting first to have 2 times negative 6x's. So how many x's is that? Well, 2 times negative 6 would be negative 12. And then I also have a positive 2 times a positive 8, which would be positive 16. Now everything else stays the same, so we now have 7x minus 12x plus 16 equals negative 14. And distribution, just like we've seen, does not actually usually simplify the equation. But what it does allow us to do is to combine like terms. And yep, we've got some x's that we can combine here. So that's going to be 7x's minus 12x's. You can put that in the calculator, you're going to get negative 5x's. So everything else remains. And to finish solving this equation, we'll have to use some principles of equality. So for me, since all my x's are already on the left, I will keep them on the left. And all my numbers then will be on the right side of my principles of equality line. Okay, so negative 5x, hey, that's on the x side. That's exactly what we want. It's good. It can stay. But this positive 16 right here doesn't have an x. So since it doesn't have an x, I got to zero it out. So how do you make a 16 a 0? Just subtract 16. And yeah, if we do it to one side, we must do it to the other side. So now I can take my negative 5x's and drop it. 16 minus 16 is 0. That was planned. We had planned that out before. We dropped the negative 5x. And then this is going to equal negative 14 minus 16. Put that in the calculator. Negative 30. All right, well, we've isolated the x's by making a 0 there. Sometimes we have to make 2 zeros, but in this case, only 1. And since they're isolated, the last thing we need is a coefficient of x that is a 1. We want this to be 1x equals, not negative 5x equals. But just like we've seen already, how do you make a negative 5 a 1? We simply divide it by itself. And yep, if we do it to one side, we got to make sure to do it to the other side. So that's going to be a 1. Negative 30 divided by negative 5 is going to give me positive 6. Now, just to emphasize, we're looking for an answer here, which should be an ordered pair. But what happens is some students look at this and they're like, hey, look, I just solved for 6. Look at all this work that we just did, and it's beautiful. It's pretty, right? But the problem is we're not done, because as an ordered pair, we have an x, but we don't have a y. So we have part of the location, we just don't know where the exact location is until we find this y value. So that's where you can use either one of these, doesn't matter. But I'm going to use this one because the x is being operated all together over here, and then it just gives me a y. So I'm going to go up here. I'm going to say, you know what, that x, so let's rewrite the equation. Y equals negative 6x plus 8. But the x value, as we just found, should be just a 6. So I'm going to take that x and replace it with 6. Since we found x to be 6, it should be 6 in either one of the equations. So since I chose this one, I replaced the x with 6. All I've got to do is solve this now, and that will give me a corresponding y value. By the way, you can put that negative 6 times 6 plus 8 in a calculator, and it should give it to you. I did it in my head, and I got negative 28. So we found y to be negative 28 then. So I take my ordered pair, and I replace the y with negative 28. This should be the solution, right? We know that if you replace x with 6, you get y equals negative 28 in this equation. But we also need to check in the other equation, so that's what we're going to do. So we're going to check in that second equation, just to make sure it is true. And that other equation is 7x plus 2y equals negative 14. Well, I'm pretty sure we found an x value that was 6, so let's replace that with 6. And we're pretty sure the y right now is negative 28. So, to check, because we're not sure, we put a question mark over the equal sign. But again, I would just type all this stuff into a calculator. That would give us negative 14. So, the statement is showing negative 14 equals negative 14. As far as I know, that's true. Since it is true, and we know that x being 6 and y being negative 20 made this one true, that means we have in fact found the solution. Three y plus 1 equals x, and also 10y equals 4x equals negative 8. So again, sometimes there's confusion about this one because it equals x. So if it helps you, just rewrite it and put the x over here. Okay, so x would equal 3y plus 1, and that's okay too. It means exactly the same thing. So it doesn't matter which one you say it is, it's the same thing. I'll just use the original on this one. So for here, I'm going to take the x, which is showing as 3y plus 1. I know x is that. 3y plus 1. So I'm going to go to the other equation, 10y minus 4x, and I'm going to replace the x with 3y plus 1. Now I do need the parentheses there, but now I have 10y minus 4 times that 3y plus 1, and then this would equal negative 8. But now that I have that, I'm ready for distribution. So I've got my negative 4 that I'm distributing into the parentheses. First up, that'd be negative 4 times 3y. Distribution is always multiplication. So how many y's would that be? Negative 4 times 3 would be negative 12 y's. And then we also have, remember that's a negative 4, and then you multiply it by 1, which would be negative 4. So if by chance you did not distribute this as a negative, you may have gotten plus 4 here, which would have given you the incorrect answer. All right? So we do need that minus 4. Now I've got 10y minus 12y minus 4 equals negative 8. So that's some distribution. Now we have some combining like terms, 10y's and minus 12y's. How many y's is that? 10 minus 12 is negative 2. So we still got minus 4, and that equals negative 8. So we've simplified that equation, and next up we'll need to zero out that minus 4 to isolate the y's. So I'm going to put y's on the left, numbers on the right. So negative 2y is a y, so it can stay there, but the negative 4 doesn't have a y. It must be zeroed out. So add 4, but if you do it to one side, do it to the other side as well. So that'll zero out, just as we planned, and then we can drop the negative 2y. And now this equals negative 8 plus 4, which is negative 4. And then the last thing I've got to do is to make the coefficient of y 1. So negative 2 can become 1 just by dividing it by itself. But if I do it to one side, I got to do the other side. So this gives me negative 4 divided by negative 2, which is positive 2. So in my ordered pair, I have an x and a y value. And this y value that we just found is a 2. Okay, well, all I need is my x value. So I'm going to go back to the first equation because it's going to be easier to solve with. We had 3y plus 1 should give us the x value. And we just found the y value to be positive 2. So that'd be 3 times 2 plus 1, which when we put this into the calculator, we should get 7. So our x value is 7. So I put that in my ordered pair. But the last thing I need to do is check, so I will. I'm going to check this second equation. 10y minus 4x equals negative 8. And we found the y value to be 2, so we'll take the y, replace it with 2. And we found the x value to be 7. So x value, instead of showing it as an x, we're going to put it in a 7. Now we don't know if this is true, so I'm going to put a question mark over my equal sign. So 10 times 2 is 20, minus 4 times 7 is 28. 20 minus 28, that would give us negative 8, which does actually equal negative 8. So since that is true, then we know we have found the solution here as 7, 2. This one's pretty much the same thing as the last one. I'm going to keep this one the way it is, though, so I'm not going to rewrite it. Yeah, this equation, it doesn't show us x equals or y equals anything. This one equals x, and that's okay, too. But I have an x equals this negative y plus 3 right there. So in my other equation, my first equation there, I can take that x and replace it with negative y plus 3, which I will do. Okay, and I am keeping those parentheses on purpose. The rest of it stays, so it's 6 times that x, so it's times negative y plus 3, minus 2y, and this would equal positive 26. All right, well, we've seen this process before. Now today we've seen it, twice? So next up, we're going to use some distribution. That's 6 times negative y, or negative 1y, if you like it, which would give us negative 6y's. But then we also have 6 times 3, which would give us positive 18. Okay, everything else is just going to stay the same. We're going to take this and drop it. So this is our new equation. And yeah, we still have the y's that we can combine, so let's do that. How many y's is this going to be? Well, that would be negative 6 minus 2, which is negative 8y's. So now I have it written as 18 minus 8y, and this would equal 26. So, principles of equality, right? We got to zero out that 18 so that we can get all the y's on the left isolated. So the 18, we're going to zero that out by subtracting 18, but if we do it to one side, make sure to do it to the other side. That zeroes out as planned. We can drop don't forget the negative there. We can drop negative 8y equals 26 minus 18, which is 8. And then the last step here is to make the coefficient of y a 1. So how do you make a negative 8 coefficient a 1? Just divide it by itself. Yep, if we do it to one side, we got to do the other side though. So 8 divided by negative 8 there on the right would be negative 1. So that's half of our answer in the ordered pair. We now know our y value is, or should be, negative 1. That's assuming we haven't made any mistakes, which we could have. But since this equation was just x equals y and some stuff, I'm going to use that second equation to solve for x. So the y value, showing as negative 1. So the full equation is negative 1 plus 3 equals x. Now if you use the parentheses in the calculator, you can type this in as just like I have it written. And when you do, you're going to get the final x value of 4. Okay, so the x value I get is 4. But let's check just to make sure. Okay, so we tested the second equation. Negative 4 plus 3 should be, negative 1 plus 3 would be 4. That would be true. But I need to check the first equation. So let's get this written out. 6x minus 2y equals 26. Okay, so we have the x value already. We know we're pretty sure it's 4. And we have the corresponding y value, which was a negative 1. So I'm going to check this. So there's my question mark over the equal sign. All of it should equal 26, though. So 6 times 4 is 24, minus 2 times negative 1 would be negative 2. That checks off. Gives us 26. That's true. And since it is true, that means we have found the solution. On the assignment, we're going to see some problems where you got to actually write the equations. So here we are. So the basic form will be based on the information given. So there's two forms that we know of. You should have something to the effect of y equals mx plus b, which is slope-intercept form. Now, it may not always come out in this exact form. You may have b plus mx or something like it. Or what we've seen as well is standard form, which is ax plus by equals c. And it doesn't matter which term is first, the x or the y term. It just depends on the scenario that they give us. I can't tell you which one they're going to give you, but I will tell you that usually it takes students several times reading the problem to determine which one is correct. So they should also tell us what variables to use and then what they should represent. But again, we should have two values that we need to solve for, which is why we have two variables, y and x. And then make sure you leave your answers for word problems, at least if you're doing them by hand. I believe on the assignment they may label those for you, though. You are deciding between two different movie streaming sites to subscribe to. Plan A costs $22 per month plus $2 per movie watched. Plan B costs $13 per month plus $3 per movie watched. Let A represent the monthly cost of Plan A. If you watch X, that should be movies per month. And let B represent the monthly cost of Plan B if you watch X movies per month. Notice they're using the same X there, right? X is movies per month that we're watching. And then write an equation for each situation in terms of X and determine the number of monthly movies watched X that would make the two plans have equal monthly cost. So, again, all of this kind of stuff, it may be new. I think we do some of this kind of stuff in 7th grade, but that was a long time ago. And no one can remember jack squat from 7th grade. So, let's take this one. We'll take it fairly slow. And if you got questions, this is where you should ask, right? So I got two plans. I got Plan A, and then I got Plan B. Let's start by writing the two equations, all right? So I'm going to start with Plan A. So Plan A right there, that's the cost for going with Plan A. Why am I doing that? Because they told us up here that we should use A. Yeah, let A represent. There it is. So A is how much it's going to cost for watching some number of movies per month. Now, just so you understand, it says $22 per month plus $2 per movie watched. This means if you were to watch 0 movies, then they would still charge you $22 for that month. You can decide if that's good or bad. It's up to you. But the cost is A. Okay, so the cost. What are the costs that we have? Well, you have two costs associated with Plan A. You have kind of like the monthly fee there. And then in addition to the monthly fee, we also have movies that you're going to watch, okay? Because again, if you don't watch any movies, you still have to pay that monthly fee. So then I'm just going to put movies. All right, do we know these values? Well, we know the monthly fee. They told us up here at the top. Monthly fee, they didn't say fee, but it's $22 per month. Maybe it's some kind of subscription fee or something like that. So our monthly fee, boom, $22. Okay, how much are we going to pay for movies, though? Well, movies, we don't know how much we're going to pay because we don't know how many movies we're going to watch. But what we do know is that it's going to be $2 for every movie. Now, if you just put a 2 there, that would represent one movie. Since we don't know how many movies we're going to watch, that's why we have to use an X. Okay, so it says X. You're going to watch X movies per month for both of them. So $2 times X, 2 times the number of movies watched, will tell you how much you would pay for just watching the movies. This part right here tells you how much you're going to pay for just the movies. And then we can add the monthly fee for the subscription or whatever it is. Okay, just usually getting to this point takes some effort, sometimes a lot of effort. Some students would write 2x plus 22, and that would be formal slope-intercept form. It doesn't really matter. But what I do have as well is, I'll do it in a different color. I have Plan B, okay? So I'm going to go with plan B. And I'll use B because they told us to. That's the cost for going with plan B. I said that right here. Let B represent the monthly cost. Okay, so that's the overall cost that we're going to pay for the month. Okay, so what would this equal? Well, you have the same two fees, or same two parts to your cost. You got some kind of monthly fee. And then you're going to pay something for watching the movies. Okay, so this one, a little bit different because they say, look, our monthly fee is only $13. Okay, well, there's $13 to pay right up front. And again, that means if you watch 0 movies, you're still going to pay them the $13. Okay, that's just a monthly fee. But then for movies, it says you're going to pay $3 for every movie. So see, they're charging more for every movie, but they're charging a lower monthly fee. Well, this 3 is just for one movie. We don't know how many movies you're going to watch. So we're going to use the same variable x like they said up here. And when you multiply 3 by x, that tells you how much you'll pay just for the movies. Just for the movies. That's not your total cost for the month because it does not include the monthly fee. But we can include it simply by adding the two together. So on this assignment, you'll have to enter this into a box. And then you'll have to enter this one into a separate box. Okay? So that's writing an equation for each situation right here in terms of x. And determine the number of movies watched. Okay, so the second part. Determine the number of monthly movies watched, x, that would make the two plans have an equal monthly cost. And then even after that, we can figure out how much it would cost. Okay, so here's what we have. We got plan A. We got 2 plans, right? So I got plan A. And I also got plan B. What it says is we want to know when the costs would be equal. So that means I'm just going to make these two equal. Okay? And my equal sign. So I'm setting it up right here. Okay, on the right. Plan A equals plan B. Well, what is plan A? Well, we found that plan A is 22 plus 2x. And then we need, so plan A is this. Plan B, so you see I substituted right there, by the way. Just using substitution or replacement. Plan B says it's 13 plus 3x. Okay, so plan B, instead of plan B, I'm going to replace that with 13 plus 3x. So, those two expressions are going to be made to be equal to each other. And now I have an equation with one variable, x. That's how many movies we're going to watch. I'm going to solve this for x. So, principles of equality, right? No distribution, no combining like terms, but I can jump straight into principles of equality here. I like to always keep my x's on the left, numbers on the right, but you don't have to. You can switch those. You should get the same answer. So let's start. My 22 does not have an x, but it's on the x side. It can't be there then, so it has to be zeroed out. So minus 22. If you do it to one side, you got to do the other side. And notice I'm putting it below the 13 because they are like terms to combine. So let's go through it. 22 minus 22, that was 0, just as we had planned it to be. And then my 2x here, I can just drop. And this equals 13 minus 22, negative 9. And then we can drop the positive 3x there. Okay, so this is helping us solve for x. I just made our 4-term equation here a little bit smaller into 3 terms right there. So the next thing I got to do is to, let's see, right? We got the 2x, it's good, it's on the correct side. The negative 9, yeah, it's a number, that's okay. But the 3x, it's on the number side. Well, it can't be there either. So let's get rid of that garbage. So I'm going to zero that out by minusing 3x's. But if I do it to one side, I'll have to do it to the other side. Now, on the left, 2x's minus 3x's would be negative 1x's. And this would equal, we'll drop the negative 9. And then 3x's minus 3x's, still 0. We had planned for that 0. Now this is good because the x's are isolated. But the last thing I need here is a coefficient of x that is 1. So I can just show it as a phantom x, a phantom 1x. So to make a negative 1 a positive 1, I'm going to take it and divide it by itself. But yep, if I do it to one side, I've got to do it the other side. Negative 9 divided by negative 1 would be 9. Now this is a word problem, so it has context though. So we can't just say x is 9, and we wouldn't even want to do this much, where it would say, look at this, I got my ordered pair, and I now know that x is 9. Okay, I mean, you kind of could. But what we need is a label for our x, because it should represent something. Up here it told us that x is the number of movies watched. Here, and it kind of tells us here as well. So the answer is not actually 9, it's 9 movies. And that should be our actual solution to this problem. The other thing you can do here is say, well, how much did it cost? So I'm going kind of beyond the problem here. Hopefully that's okay, but how much would the two plans cost? Well, we can figure that out. You can use either one of these equations, but it should be the same cost, right? So you could have used A or B. I'm going to skip the math on this, but 18 plus 22, 40. So if you watch 9 movies, plan A is going to cost exactly the same as plan B. I got 40 of this one. 3 times 9 is 27 plus 13. Yeah, $40. So you could have gotten the ordered pair 940. But again, it's a word problem, so it should represent some stuff, like it does. There's our objectives again. So the first part, even the bell work had some systems of equations with substitution. We did use some substitution with the word problems though, right? Plan A and plan B. So if you guys feel comfortable with that, the assignment will go well.